Alrighty, so this is my larynx that I made. First, I'm going to start off naming the structures. We have the epiglottis in pink, hyoid bone in blue, thyroid cartilage in yellow, and then at the bottom we have the cricoid cartilage in red. And then if we're looking at the back here in purple, trying to point, we have the arytenoid cartilage of the vocal folds. Black represents the vocal folds themselves. In pink in the back, we have the oblique arytenoids, and then in blue, we have the transverse arytenoids, and those two muscles make up the inner arytenoids. And then in green, we have the posterior cricoarytenoid muscles. And then up front, if we're looking anteriorly, we have the cricothyroid muscle. So this muscle can articulate via the cricothyroid joint, represented by this little brass, I don't remember, brat, I think is what that thing's called. And then the cricothyroid joint connects the cricoid and the thyroid, obviously. And it's formed between the inferior horn of the thyroid and then the thyroid articular surface on the cricoid cartilage. And it articulates, again, like so. And then the epiglottis is attached to the thyroid by the epiglottic petiole. It functions to cover the vocal folds during swallowing. The hyoid bone sits superior to the thyroid and is attached by both muscles and ligaments. And then here are the vocal folds. One fell down. I just can't get these things to stay. Sorry. Oh my goodness. Oh goodness. All right, so purple represents the vocal folds. They are kind of far apart right now because they won't stay. Okay, in purple, here are the the arytenoid cartilages of the vocal folds, which are made, and then the vocal folds themselves are represented by the black string. The vocal folds are made up of 5 layers, and the vocal folds can adduct, which means close together, by both the transverse and oblique arytenoids, which are also known as the inner arytenoids, and the lateral cricoarytenoid muscles, which is on the inside in green, and that muscle is connected to the cricoid cartilage and the arytenoid cartilages of the vocal folds. The lateral cricoarytenoid, the inside green, helps bring the vocal processes together so that the vocal folds can truly close without leaving a gap. And then, so when those contract, the vocal folds close. And then the transverse arytenoids, transverse here in blue, contract and help the arytenoids glide together. When these oblique arytenoids contract, they help pull the apex of the arytenoids to adduct. Adducting means it keeps the voice from sounding breathy. The only muscle that abducts the vocal fold is the posterior cricoarytenoid. This muscle contracts and pulls the vocal folds away from one another. So the cricothyroid muscle that I showed up front pulls the arch of the cricoid cartilage upwards. So it pulls it upwards. In doing so, it pulls the arytenoid cartilages backwards. If you can see, I'm moving it upwards. The arytenoids are moving backwards, making the vocal folds longer and tighter. And then in making the vocal folds longer and tighter, this causes the vocal folds to vibrate faster and thus increase the pitch of the sound. And then the thyroarytenoid, which is the represented by the string, or the vocal folds. These muscles form the body of the vocal folds themselves. So they consist of both the vocalis and the muscularis. So the vocalis muscle, which would be a part of the black, when contracted, will lengthen the vocal folds, and lengthening increases the pitch. And then when the muscularis portion of the black vocal folds is contracted, it pulls the thyroid cartilage. So the thyroid cartilage and the arytenoid cartilages closer together. And then this puts slack in your vocal folds, which lowers the pitch. And then, so as far as loudness goes, the subglottal pressure beneath the vocal folds, so coming up this way directly correlates with loudness. So the more pressure that you build up, the louder you will be. And then I will show you the process of one oscillation of the vocal fold. So first you have the vocal fold, which adducts completely from the bottom from the positive pressure. The subglottal pressure rises, and then this inferior part, once the subglottal pressure, positive pressure rises up enough, the inferior part opens, and then the superior part opens while the inferior part closes due to negative pressure. And then, so as the air goes through the narrow glottis, the velocity increases and the pressure decreases, which is the Bernoulli effect. And then the superior part of the vocal fold closes. So I know that was hard to show in slow motion, but it starts inferior closes first, and then superior, and it's just keeps going like so. I don't know if I'm showing it to the best of where it makes sense, but inferior portion of the vocal folds open first due to the positive pressure, and then the superior opens and the negative, or the inferior closes due to the negative pressure buildup.